The Web and Internet Science Research Group at the University of Southampton is pleased to introduce two new open source libraries and tools for the analysis of multimedia, the culmination of over 6 years of research. Together, these libraries won the open source competition at ACM Multimedia 2011. The first of these libraries is OpenIMAJ, a broad library that contains everything from state-of-the-art computer vision and advanced data clustering to software that performs analysis on the layout and structure of web pages. The OpenIMAJ software is structured into a number of modules that can be used independently: analysis and processing for images, video, audio and web documents, state-of-the-art machine learning techniques including scalable clustering and KNN implementations, and hardware interfacing libraries for audio and video devices, the Xbox Connect and other hardware like serial GPS receivers. OpenIMAJ also contains tools built on top of these libraries, some of which have Hadoop MapReduce implementations. OpenIMAJ is primarily written in pure Java, so is completely platform independent. The video capture and hardware libraries contain some native code, but Linux, OS X and Windows are supported out of the box. It's possible to write programs that use the libraries in any language that supports Java bytecode. You might think that, being in Java, is going to be slow, but here's OpenIMAJ performing key point matching on live video from a webcam. First, we create a model by selecting a region from the video, and then this is matched against the live video. You can see the matching is rotation, scale and translation invariant and runs in real time. One of the key motivations in our implementations has been to make it easy to use and extensible. To show this, let's create a really simple video analysis program to see how easy OpenIMAJ makes it. In our main method, we will create a video capture object with a preferred frame size. We can display the output of this using a video display object. The video display object has static methods for its construction. If we run this, we'll see our video in just 2 lines of code. We can perform analysis on this live video using a video display listener. This interface has 2 methods, one which is called before the image is displayed and one which is called afterwards. We'll alter the image before we display it. We're going to perform inter-frame subtraction, so we'll create a field to store the previous image. We'll make a copy of the incoming image and subtract the previous image from it. We'll then store the incoming frame for the next time around. When we run this, we'll see we have a frame subtraction program in no more than 10 lines of real code. We can change just 1 line of code and this analysis can be performed on a video file. To do this, we replace the video capture instance with a Zuggle video instance. This is a class that uses the Zuggler library to read video frames into OpenIMAJ. Run the program and our analysis happens on a video file. Now that's flexibility. It's clear to see that this philosophy of easy-to-use extensible software allows researchers to build complex applications quickly. Let's dive into a bit more complex code for a minute. This bit of code performs key point matching between 2 images. We're using a class that extracts the dominant orientation from an orientation histogram, but we can easily swap this with another implementation, say an implementation that is not rotationally invariant. We could even change the regular SIFT feature provider with another feature provider. You can see the effect these simple changes have when we run this demo. Initially the points match, but as the image rotates, only the rotationally invariant features in the top image continue to match. A comprehensive tutorial of OpenIMAJ is available for download on our website. The other tool we jointly released with OpenIMAJ is ImageTerrier, a fast, scalable image content search engine, and like OpenIMAJ, it's ideally suited for research into multimedia retrieval using bag-of-words techniques. ImageTerrier is built on top of the Terrier text retrieval platform and implements a state-of-the-art single-pass indexing technique that produces highly compressed indexes. The terms indexed are vectors of features extracted from images. The query engine provides the means to query against the index and re-rank the results, all in a scalable, extensible way. Like OpenIMAJ, we have built tools on top of these libraries, some of which have Hadoop MapReduce implementations. ImageTerrier has been demonstrated to index and search a corpus of over 10 million images containing a lexicon of around 10 billion quantized SIFT visual terms. But for now, let's have a look at a simpler example. We'll use the ImageTerrier tool to index this set of images. We can use the main command line tool to do this. We'll simply tell the ImageTerrier tool that we'll use the basic indexer on a set of images, that we'll write the index to a file called index, and that we're going to use SIFT features. ImageTerrier will extract the features from the images, quantize them, and create an index. Once we have the index, we can query the index using the basic searcher tool with a query image to find similar images. The -D switch will make the tool display the results. Using ImageTerrier, we built a web application that provides building recognition. Querying with an image that has no metadata, we are able to estimate the location of the photographer. This is because the index is constructed using 150,000 geolocated images from Flickr. The location of the unknown photograph is estimated by averaging the locations of the largest cluster in the visually matching images. Both ImageTerrier and OpenIMAJ are released as open source projects and binary dependency bundles for use with Maven or other dependency managers. It's necessarily been a brief overview of the two projects, but we hope that it's given an insight into how powerful these tools are and how they release researchers and programmers from some of the mundane aspects of complex multimedia analysis in Java.